guys, here we are again. Next math notes 3.2.3, graphing two variable inequalities. Much like graphing one variable inequalities, we're extremely similar to solving equations. Graphing two variable inequalities is going to be very similar to just graphing regular two variable equalities. But let's take a look at it. To graph an inequality with two variables, first you're going to graph the boundary line or curve the same way you would if it was an equality. If the inequality does not include the equality, that is if it's greater than or less than rather than greater than or equal to or less than or equal to, then the graph of the boundary is dashed to indicate that it's not included in the solution. Otherwise, the boundary is a solid line or curve. So if you see greater than or less than, you're going to get a dotted line. If you see the greater than or equal to or less than or equal to, you're going to have a solid line. So that would be dashed, solid. Okay. Once the boundary is graphed, choose a point that does not lie on the boundary to test in the inequality. If that point makes the inequality true, then the entire region in which the point lies is a solution. If that point makes the inequality false, the entire region in which the point lies is not a solution. So, in other words, you're going to pick a point above and below the graph, and you're going to see which direction you need to shade. I would recommend doing what they've done here in the first one, and anytime that it is possible, test 0, 0, because 0, 0 is a nice, easy point. So we started off down here with y equals less than negative 2/3 x plus 2. We considered it as equal to negative 2/3 x plus 2. That gives us a y-intercept of 2 and a slope of down 2 over 3. We see that this is less than, does not have an equal sign, so we did a dashed line. And now we're going to test this point, 0, 0, to see whether it makes the inequality true or false. So we plug in, remember this was our equation, or sorry, our inequality. Plugged in 0 for x, 0 for y, and we end up with, on the left-hand side, 0. On the right-hand side, we have negative 2/3 times 0 plus 2. So negative 2/3 times 0 is 0, plus 2 is 2. And 0 is, in fact, less than 2, so that is true. So that's included in the solution region. And we're going to shade everything below the dashed line. So what that means is that any point in that region is a solution to the inequality, and any point in the unshaded region is not a solution. Let's take a look at one with a parabola. So here we have, if we were to just graph this line, we would have y equals x squared minus 1. So you guys should be used to that as a parabola that's been shifted down 1 from the mother function. So we're down here at 0, negative 1 for our vertex. We're going to go up 1 over 1, up 1 over 1, over 2 up 4, over 2 up 4. And because down here we have an equal sign included with our greater than sign, this is going to get a solid line instead of a dashed line. All right, so we're looking down here at the inequality now. So it's solid because there's an equal sign there. And we're going to use, well, they're going to use 3, 1 as their test condition out here, just to show you that you don't have to use 0, 0. So when you plug in 3 for x, 1 for y, you end up with 1 is greater than or equal to 3 squared minus 1, which is 1 is greater than or equal to 8, which is false. So it must be shaded in the other direction. Just to sort of do a quick test on 0, 0, since I suggested you do that before. If we do that, we get 0 equals 0. Alright, 0 is greater than or equal to 0 squared minus 1. 0 is greater than or equal to negative 1. That's true. So there's another indication that we're going to shade inside or above our parabola because it's true in here and it's false out here. Okay, let me leave you with one for you guys to try on your own. Let's give me the graph of y is less than or equal to negative 2 times x minus 3 squared plus 5. So graph that, shade it, tell me what you get, guys, and we'll talk about it in class.